Hi again, my name is Gene and I'm a new mentor for high school robotics team FRC 714 from Newark, New Jersey. This video series is about how easy it is to program FRC robots in Python, the language of many modern apps and most AI products. If you are a mentor or a student thinking of switching all students on your team to Python, please go ahead and start using our examples and never look back. Every student on the team will thank you later when they start looking for engineering internships or jobs after graduation or in college. And today with us, we have a robot generously provided by our sister team, 8630. As you can see, this robot has an arm, and on that arm there is a single motor intake. When the motor spins forward, the intake can take game pieces in, for example, my wife's boot. But when the motor spins the opposite way, it can eject the game pieces out, like this. The motor is connected by belts to 3 different shafts, which all spin consistently in the correct direction. And our goal for today is to add the code to drive the intake subsystem. To start, let me just say that this motor has the CAN ID 9. This is the address of the motor on the network of the robot. Let's get to it. You might ask, what is stopping the intake from intaking the shoe further after the shoe is already inside? What's stopping the motor is a limit switch, the switch that tells the motor that, hey, stop, you are at the limit, do not spin anymore. How does it work? In this case, the limit switch consists of a brake beam sensor, which is, there is a little source of infrared light in here, and you can see it in your phone camera, for example. And a light sensor in here, such that when a game piece, like a shoe, gets in, the source of the light, source of the beam of light, and the light sensor, the beam is broken, and the switch is enabled, which tells the motor to stop spinning further. This is how the intake knows that the game piece is now inside, because the light beam is broken, brake beam sensor. Today we're going to be adding the intake with a brake beam sensor to a swerve drive robot. Link in the description. This is the location of an example swerve drive robot code on GitHub. You can actually add it on top of a tank robot just as well. It will just work, don't worry. Because this is a swerve robot from our sister team, I'm doing it on top of a swerve robot. But if you have a tank, just follow exactly the same step and you can add an intake to a tank robot instead. So link in the description. I can go to this repository on GitHub, and what I can do is I can open PyCharm to start building on top of the swerve robot. If I have some other project open, which I don't, I can close it, but for now I'm going to say get from VCS, because I'm going to get the base swerve drive code cloned. Alright, so at this point I have the swerve drive robot code cloned, and I have robot container, which is most important for what we need. Plus, what we need to do at first is we need to choose the version of Python that we like. We must click on the lower right corner where we choose which Python interpreter to have, and what I recommend is that we add a new interpreter. Add a new local interpreter, which will create a virtual environment. I pick version 3.9. You're welcome to pick whatever you want. So long as it's not too far from 3.9, it should work just fine. We're creating a new virtual environment, new PyCharm virtual environment. Here I'm selecting new. The location of the virtual environment, if you're an advanced user, you can put it somewhere else, but I'm just gonna use the defaults. I hit OK, and the new virtual environment with Python 3.9 is ready for us to use. What we must do next is we must go to the requirements file. I'm gonna click on requirements.txt in here, and we should be given an option to install all missing packages. Yes, click. Approve, approve, approve. Everything is going to get installed. If for one reason or another they're not installed for you, you can always open a terminal like this, and you can say pip install -r requirements.txt and hit enter. And you will feel a little bit like a hacker, maybe, because you're using command line. Now, absolutely everything that we need is installed. PyCharm is taking its time, it's indexing, which is, it's making things searchable if you later need to find something in this project. But for now, what we have is we have a working Swerve Drive robot. First thing to do is to sync, which is to get all the dependencies downloaded while we are connected to the internet. I'm picking the sync option from the menu above, and I'm going to run this. Lots of dependencies, which are components that we need, are getting downloaded from internet. Completed. Press enter to continue. Now we are ready to go ahead and actually start adding a new subsystem to our robot, an intake. So on my GitHub, I actually put a bunch of code snippets for adding different subsystems and commands to your existing robot. Link in the description. We're going to exactly one of those examples today. I'm going to open the Chrome web browser. I'm going to put the link for where I put all the examples. It's actually the same link as the repository above. And if you scroll down here, these are the other things that you can add to this or to similar robots. It will work on a tank robot or on a Swerve robot, it's all fine. You can add an arm, a camera, which we already did. You can add an intake and a shooter and some commands also. Today we're adding intake, so click and see. First, this is the code snippet for adding a single motor intake. And it must go to a file called subsystems/intake.py. So I'm going to go ahead to the subsystems folder and create a new file. Intake.py in there. The file is empty. I don't have to add it to Git, or you can add it to your Git, your choice. I'm going to copy the example of an intake subsystem and just paste it in here. Let's look through it a little. So 9 is the CAN address of the motor, of the intake. If your intake motor has a different address, for example 13 or 6 or 1, you have to change this. This constant is the speed at which the intake must be spinning. Note that this is not RPM, this is not revolutions per minute, this is a set point. Set point is a convenient unit that goes between -1 and +1 for motor speed. 0 means the motor is stopped, -1 is full reverse, +1 is like +100%, full forward. Inside of the intake subsystem, you can see that there is only one motor that has the address in question. And what the intake can do is it can intake a game piece, by enabling the limit switch and spinning the motor forward. It can eject a game piece by disabling the limit switch, the brake beam limit switch, and setting a negative speed to eject the game piece out of the intake. And finally, it can actually feed the game piece forward through the intake completely to the other side into the shooter. What you want to do is you want to disable the brake beam limit switch and continue feeding it forward with the maximum possible speed so that hopefully it accelerates before being shot out. These are the three things that this intake can do. And what we need to do to make it work is we actually need to add some code inside of robot container. Why? In order to drive this intake. First, we're going to add this little code snippet inside of the init function to say that my robot does have this intake subsystem. I go to my robot container.py. I'm gonna need to find the init function. Sometimes we call this function a constructor. And look, these are all the subsystems that this robot has. For now it only has one subsystem, the drive subsystem. So let's add another one. Let's add the intake right into here, inside of the init function. Now this robot has the intake subsystem also. But we cannot drive it until we assign a joystick button to drive the intake. So we try to assign all the button bindings in a function called configure button bindings, also inside of robot container.py. So these are lines of code that need to be added to configure button bindings function. Let's go find it here. Configure button bindings here. This function is all the way here on the bottom. It really doesn't matter where we add this code. We can add it at the start to keep it simple. Boom. I have added the button bindings for the A button of the joystick. When the A button of the joystick is pressed, we're going to run. Pressed means true. When the button is pressed, we say the button is true. We're going to add an instant command to start the intake of the game piece. And we're going to block access to the intake subsystem so no other command tries to use it at the same time. And when the A button is unpressed, no longer pressed, we call it the button is false. The button value is false. Then we add another command to stop the intake. So if you go back to intake.py, there is another function that this intake has, the stop function. It's very simple. We just set the motor speed to 0 and that stops the intake. And we're also printing out the a little breadcrumb so that we can see that the stop function was called. Finally, we're adding the B button. B button is the button B on the joystick. And to this B button, we're going to hook an instant command to start ejecting the game piece, which is to spin the motor in reverse by blocking the intake for anything else. And when the B button is unpressed, becomes false again, we're going to stop the intake from ejecting the game piece further. I don't know if all of them will work because there is something else that needs to be added. So if some of the symbols are showing up as unresolved, we need to add this piece of code in the beginning of robotcontainer.py. Let's do it. Let's make sure that this piece of code, these imports, are added to the beginning of robotcontainer.py. Honestly, they are already here, but maybe they are not here in your robotcontainer.py. So just to be sure, I have added them to the beginning of robotcontainer.py. Here, I think it should work, but in order to be 100% sure, we can always run this code in simulation. Shall we? I'm switching to the simulation configuration and I'm hitting run. Something did not quite work. Run command is not defined. So in addition to instant command, we must also import run command. I'm going to fix the example. But let's try simulation right now. This is why it's a good idea to run things in simulation, because if you have anything that's broken or any errors, simulation will help you find many of them. Let's run this in simulation now. Okay, now the simulated robot comes up and seems to be happy. We also have our green joystick. It's called Xbox controller. And what you can do is you can say, hey, this Xbox controller is going to be my joystick number 0. We're going to switch the robot. We can just check. Hey, if I press buttons on this joystick, I see the buttons as being pressed here at the bottom. I'm going to drag this window a little bit further up in here so we can continue watching the joystick. While in the meantime, we can also watch the output of the program in here. I'm going to switch the robot, the simulated robot, to the teleoperated mode. And I'm going to press the A button to see what happens. Will the intake work or not? Let me just rearrange the windows a little. So the robot is switched to teleoperated. I have the joystick in my hand and I'm going to push the A button, which is the intake button that we wanted to operate the intake in the intake direction. Push. And what we see on the screen is the code has printed out that the intake game piece function is called. So the simulated motor is supposed to start working to intake the game piece. Now I'm going to unpress the button. And what I see on the screen of the simulation is now the intake is stopped. Now let's try the eject button, the B button. I'm pushing the B button. Push. What I see is a breadcrumb that says eject game piece. Now I'm going to unpress the B button. And I see intake is stopped. So I think the code works in simulation. Time to deploy it on a real robot. I'm stopping the code. I'm going to go refresh the list of my Wi-Fi networks. Connect to the robot radio 8630. Rubble is my dog's name. And now that we are connected to the robot, we should be able to deploy this code to the robot. I'm switching to the deploy configuration, hitting run. I'm asked what's the team number or the robot host name. Team number is 8630. Team number is needed because in order to deploy the code, we need to know the IP address of the robot. Let's do it. It says deploy was successful. So let's fire up our driving station. Here I have it. It's already connected to the robot. And let's see if the intake works. I'm switching it to teleoperated, hitting enable, and turning the screen to the robot. Here's the robot. It has approached the game piece, and I'm going to hit the A button on the joystick, the intake button. The game piece is in, and after it broke the light beam of the limit switch, the motor is not pushing that game piece anywhere further because the limit switch has been enabled, engaged. Now let's test the B button, the eject button. This button, as you saw in the code, completely ignores the state of the limit switch and will just eject the game piece back. Perfect, everything works. Today we have added the code for an intake subsystem with a single motor and the limit switch. Next up, we're going to add the code for this shooter so that not only we can take the game piece, but we can actually shoot it out. Until then,